afternoon, everybody. I plan to do this one, right? But I got two versions. One is Mandarin version and one is English version. So, I will send. If I got time, then I'll do this one. Alright. So first of all, we are going to go for my homework. This one, no, this one, no. Okay. Wait lah. This one. Okay. Why cannot lah? This one. No leh. Oh. Great. Oh, okay. I got the double name of this one. Same name as this one. Okay. Already open? Wait. Okay lah, whatever. Okay. Alright, I can find that many of you not doing well for this question. So you have to read properly to get the mark in your exam. Alright. So congratulations for those who have done it. Alright. Some of you already sent me the answer. Right. Very good. So but not all of you doing well. Okay. Before we start, if you got any question want to ask, you can ask in the WhatsApp group, or you can I will prefer you to do it in the Telegram group, or you can ask in the Telegram group. Even you are my student or you are not my student, you can ask the question there. I will answer you. I try my best to answer you. Alright, so before we start, if can you help me to click the like. If you want to share to your friend, it is okay. Thanks for sharing to your friend. And if you are interested into my tuition, you can click the link that I sent it above there. If you are not my student. Alright. My tuition will be, we are going to have two kind. Alright, one is Mandarin version, the other one is English version. So 我有英文和华语的啦。So today I'm going to use English. Alright. We discussed the elasticity essay question first, or you want me to do the revision first? If you want me to do the revision first, I think I keep on repeating. It is like Alright, we do the question first. Alright. Okay. 9.1 and 9.2 shows the two identical springs. Alright, 9.1 and 9.2. You can see these two. 9.1 and 9.2. I make it bigger. 9.1, 9.1a and 9.2a shows two identical. So these two identical springs are compressed by two identical trolleys at the same compression distance. Alright, you compress and then you compress. And then 9.2b and 9.1b and 9.2b, this one and this one. Alright, so this one and this one are showing the position of the trolley after the compression force is released. You let go, and then the elasticity of the spring will make it move. Alright, so what is the meaning of elasticity? So this one, most of you can do it well because you just copy. Alright, elasticity is ability of the object or spring to return back to its original shape and size after the force applied is removed. right? You remove, then it still can return back. That one is called elasticity. Ability of the spring to return back to its original shape and size after the force applied is removed. This one, the 5 mark one, I can find it many of you not doing well. You see, get 2 correct only, 3 correct only, right? Only 1 get full. So most of you are not doing well. All right, I just show some part only, right? Most of you not doing well. Okay, I just show some of your answer. Many are not getting full mark. So I want to show you how to get a mark. Using 9.1 and 9.2, actually is 9.1a and 9.2a. But here it said that 9.1 and 9.2 because the question related to all. Okay, compare the compression distance of the spring. Compare this one, 9.1b compressed or not? No. Release. 9.2b compressed or not? No. If you are answering me this way, like 9.2 more than 9.1, what 9.2? Which 9.2? 9.2 this one or this one? I don't know which one. So you cannot answer in that way. All right, I know what is your answer mean. I know what do you mean, but you should not answer in that way. So you must answer 9.2a more than 9.1a, right? So you just copy here, compare the compression distance of the spring. The compression distance of the spring in diagram 9.2a more than 9.1a. So I don't want, I want you to use the word of, right? If you want compression distance of the spring in 9.2a more than 9.1a. This one compress more, this one compress less. You can see here I push compress more, this one compress less. All right, so now if you want to put it in word, okay, you can use more, you can use longer, right? You can use greater, right? I mean, the compression distance of the spring in 9.2a is greater than 9.1a. So I will prefer which one. If really prefer, I will prefer this one, greater. Greater, no matter what you use, will be correct. Right? Some of you using this way, I find compression distance spring. Okay, this one okay. This one okay, this one is correct. Wait compression distance. Okay, this one is correct. Yeah, I want to find one more that is like not so right one. Okay, I try this one. Okay, you see I want to show you. Okay, now compression distance of 9.1 is longer, right? Which one is longer? Which one is shorter? So greater, it is better. If you use longer, not so nice, the sound. All right, so you see this one is longer compression distance, this one is longer, this one shorter, so this one greater, so you use greater will be better next time. All right, you use greater, or you just use the symbol. Oh, patut lah, I open this one, cannot open. If I open this one, then patut lah. That's why I cannot open. Just now I tried to open, cannot. It said that I already opened. Okay. Okay. Yeah. Okay. I will prefer greater. So next time when you see, use greater. No matter what, longer, more, great, whatever. So you use the word of greater will be better. All right. Now next one. The distance moved by the trolley and compare the distance moved by the trolley. So this one is, which one is moved? This one is not moving. This one is not moving. So this one is released. This one already moved. So it is B. So the distance moved by the trolley in diagram 9.2 B. B. B, this one B, move, this one not moving, this one also move, but not moving that much. This one moving more. So more than 9.1 B. If you don't put A and B, you won't get correct. You cannot get correct. You can say the distance moved by the trolley in 9.2 B greater than 9.2. Alright, so this is the second mark. Yeah, this is easy, but most of you cannot get the mark. Now, the diagram, the distance move already, so compare the elastic potential energy. So which one, right? Do you think A or B store energy? Elastic potential energy. Answer me. Do you think diagram A or diagram B store the elastic potential energy? Right? Which diagram? A or B? Diagram A or B? Answer me. Should I say A? Yeah? Yeah, this one you press, then you got energy store. You press, then got energy store. This one release, it changed to kinetic energy already. This one is called kinetic energy. This one is not. So now if you answer in this way, elastic potential in 9.2, this one, this one, no. So it is not logical. So you must mention A and B. All right. So that's why you cannot get the mark. Right? Yeah, it is easy. It is easy, but get the mark, it is harder. E. Oh, okay. The elastic potential energy stored in the spring in diagram 9.1 A more than 9 B, sorry, 9.1 9.2, I'm sorry, 9.2, you press more, right? 9.2 more than 9.1 A, right? You can use greater also. Okay, this one annoying. All right, so this one, most of you not getting the mark from here. Okay, but this one most of you are okay. Now relate the compression distance, right? The spring of the spring with the distance move. All right, you compress this one and this one release, this one distance move. The more that you compress, the more that you move. The less that you compress, the less that you move. All right, so you can say the greater the compression distance of the spring, the greater, right? The further, the greater, the longer not so good. So I always prefer the greater. The greater the distance moved by the trolley, right? Always use the word of greater, remember. Now, next one. Deduction regarding to the relationship between the compression distance of the spring and the elastic potential energy. So the higher, the greater the compression distance, the greater the compression distance of the spring, then the greater the elastic potential energy stored in the spring. Just copy it. Okay, that's all. Okay, this is a 5 mark, right? 5 mark. Now, There are few factors that affect the stiffness of the spring. There are few factors affect the stiffness of the spring. Give me 2, right? You got 4. Now here you can write 3 of them, all right? So one of it is length of the spring, right? One factor, right? Then you see 4 mark, then you give 2. They said you give 2 and then explain, right? So now you explain. Now, most of you are doing well. Yes, most of you are doing well, right? Length of the string, the longer the string, the less stiff the spring. Yes, okay. But some of you not writing it well, like how let me show you. Where? Okay, not this one. Okay. Now this one, the length of the string, the diameter of the string, you answer together. And then the shorter the string, the stiffer the string. Yeah, I know. But what do you mean is this one, yeah, this one is for this one. This one is for this one. Then how do I know which one is for which one? So you better for you to write them separately. 分开写，不要写在一起啊！你写在一起，you know what I mean lah, right? I don't know which one is which one, right? Like I know which one is which one. I takut they don't know which one is which one. So you don't mix them together, right? Okay, then explain. Right, length of the string. The longer the spring, right, the less stiff the spring. It will be okay if you write into this way. The longer the string, the less stiff the string. Alright, so next one. Alright, next one is the diameter of the spring. Diameter of the string, diameter of the coil also can. Diameter of the spring, diameter of the coil of the spring also can. Okay, so the larger the diameter of the string, the larger the diameter, the less stiff the spring. Right, now they said stiffness, so you don't mention about the spring constant here. You don't say, oh, the larger the string, the less the spring constant. Yeah, the spring constant is this one. They already mentioned stiffness, so you said stiff or not stiff. One more, actually got one more, right? One more is the diameter of the wire of the spring, all right, or cross-sectional area of the wire, all right, also can. So, or thickness also can, all right, or thickness also can. All right, thickness of the wire also can. All right, cross-sectional area of the wire or thickness of the wire of the spring. All right, so how? Right, I use the first one, diameter of the wire of the string, diameter of the wire of the spring. Right, the larger the diameter of the wire of the string, the stiffer the spring. All right, so this is how you can get 1, 2, 3, 4. Just choose 2 to answer. Choose 2 only. 选2个来答啊，不用写这么多。Okay. Now come to this kind of question. All right, this kind of question, many of you not doing well, right? And okay, now let me read the question. Diagram 9.3 shows a trampoline. All right, trampoline, 弹簧床. It is used the elastic property of the material to bounce a person upward. All right. Now, fabric. Here, this is a fabric. And then this is a frame. Outside here, it is a frame. Right? You can see this outside here, it is a frame. Right? Inside here, it is a fabric. Middle here is fabric. So now here it is tied with a lot of spring here. So this one is a spring. The spring. Yeah, the side here, all the spring. This one, all the spring. So this fabric is tied with the spring and then connected to the frame. And then you can jump tum 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 tum. Alright. Now, you are required to give some suggestion to improve the design of the trampoline so that it can use by the children safely and jump higher. Right? Explain the suggestion based on the following aspects. First one, the number of the spring use. The number of the spring use. So the number of the spring use is, now you will tell me, Cikgu, series or parallel. This one is not series or parallel. You see the number of the spring here. Now, if I use I make a new one, my trampoline with one spring, 2, 3, 4 only, and then you jump. You think can? So of course there have to be more, right? Okay. So now first one, right? More number of springs, right? Many number of springs, all right? Then you explain, right? So normally I will put it into this way. Wait a characteristics, and then here I put reason. All right. So more number of string. Why? What's the reason? Reason is, now some of you say I see your answer. I'm sorry. Right. Some of you write high elasticity. Now this word is wrong here. For here, high elasticity is wrong. Right. I'll tell you why. Right. So now, if you say more spring, increase the elasticity, this word is wrong, right? Not the word's wrong. The concept is wrong, right? Here, more stiffer, yes, okay, right? Now, better bounce, okay, rebounds, yeah, you can bounce back higher, yes, okay. But if you said more elastic, now, okay, now you see, one spring, right? If what is elastic, it can go back to the original position or not. So more spring and less spring, it is more elastic. It's nothing to do with more elastic or less elastic. All right. For example, now you see if I got one rubber band. Wait, I find one rubber band from here. This is okay. Now, how am I going to do that one? Now, this is one rubber band only, so it is elastic. Right? If you pull 10 together, like cannot really pull. More number of string, it is more elastic. No. It is stiffer, harder to pull. So, it is nothing to do with elastic or not. Alright, so, this is not correct. So, now I want you to know it is more number of string, it is stiffer. Right? So stiffer, then what happened? All right, so now just now you see Darren answer better rebounds. All right, better rebound. Okay, why better rebound? Stiffer is better to rebound. Is stiffer, energy stored in the spring. Stiffer mean the K is higher. The spring constant, it is higher, so E is equal to half kx squared. So your K higher mean the E is higher. Energy more, you can store more energy, so you can bounce higher. Now, if the more elastic one, once you step on it, it sink down. Then, not stiff enough, not very stiff. So you jump, then it sink like, Cannot. Okay. So more number of string. Where? Number 2, spring constant. Higher spring constant. So why? Right? Now, this one you write stiffer, this one you want to write stiffer, can or not? Can. Can. But if you don't want, higher spring constant, like more care, can store more energy. Right? Can bounce higher. Okay. Yeah, this one, if you write can store more energy here, okay. Can bounce higher, okay. Stiffer, okay. All okay. Right? This one, okay. Right? You can rewrite the same one, can. As long as they are correct. Right? The material of the frame. Material used for the frame. This frame use what? For those you are not sure which one, then you don't write the name of the material. Right? For those who are sure, then you write steel. Yes, okay. Now some of you write aluminium. I don't think aluminium is suitable. Aluminium, unless you say aluminium alloy, but you say aluminium, definitely cannot. You see the aluminium tin, so easy to be crumpled. Now mana tahan, how can it hold? How can it tahan? Oh, cannot. Steel. Now if you're not sure, use the word of stronger material. Okay, you use this one. If you're not sure it is steel or what, use stronger material. Or if you want to write others, right, you can write here, right? Why you use steel? Not rust easily, right? Not break easily, right? Stronger, right? Not break easily, right? Can last long, last longer. Okay, right? So if you're not sure, don't choose. All right, don't choose. Okay, material used for the fabric use here. Now, to be honest, I am not sure which one until I go online search. All right, I'm not sure. The original answer also not giving you the what. All right, this one is the one I copy for. Wait, I see. Wait first. See. Wait. Okay, here. This is the answer. All right, I'll show you the answer. Okay. Length of the string longer or less stiff. Okay, any two. Material with explanation is reject just now. All right. Here. Now, material use of the fabric is hard or strong, not break easily. All right. You see, material use for the frame is steel, right? It's steel. All right. Why? Okay, you can write this. Stronger what? Or you write stronger. But this one, you're not sure. You just write hard or strong. Right? Hard or strong. Wait, where is it? Why hilang mana? Where is it Oh, here. No leh. Here. Okay. So number 4 is the material used is hard or strong, right? Material strong or hard for the fabric use, right? Material of for fabric, right? Now why? Right? Not break easily, right? last longer, right? Yeah, will be okay. All right. Now, until I use this one, all right, I got a nice search, all right. Some of you write it, all right. Even I also don't know. It is called polypropylene. Polypropylene trampoline for the fabric. All right, polypropylene. But I don't think you should memorize until like unless you really know, right? Unless you really know. If not, you write strong, you write hard will be okay. Not break easy, not tear easily. Yes, right. Some of you write not tear easily. Yes, right. So some of you Paul, you see I mark it wrong. Right? I don't know. I'm sorry. This one should be correct. Right? I'm sorry, huh? I I I haven't find it. Right? The schema don't have it. Alright. I'm sorry. Alright. I'm sorry, huh? I'm really sorry. Alright, some of you write it. Alright. Flexible and last long. If just now this one wrong, then this one will be wrong. So even though I don't know. Okay, you see? So bad. I don't even you tell me next time I also forget about polypropylene. Right? I cannot. Chemical name. I really cannot. You see, some of you write it. Waterproof, yeah, logical, yes. Because you want to put outside. So when you jump, it not waterproof, then how? So this one will be okay. Now plastic, you know plastic bag? Plastic, I don't think so. I don't think so. But polypropylene is kind of plastic or not, I'm not sure. So I guess it is cannot lah, I guess lah. So you don't use that one. Alright. Okay, let me check. Strong, high elastic fabric. Yes, very good. I like it. I like this answer. Alright, I like this answer. Alright. Now, extra fitting or design of the trampoline used to ensure safety. Okay. Extra fitting. Fitting is the one that you wear. You can wear what? Right? Or design of the trampoline. Right? Or trampoline. Right? Design of the trampoline here. Right? Some of you said this one none of you answer. Many of you not answering. Right? So area of the fabric big, then you can ensure the safety. Now I don't think so. You know what? The kid if you know, then it will be most of them will jump at the middle, right? But not all of them will jump at the middle. Some of them will jump at here. Some of them jump at here. Some of them jump at here. You ask me why? I don't know. Right? If you got kid, then you know already. So some of them will jump at the middle, but not all of them will jump at the middle. Right? They will jump at the side. Even it is big also, they will jump at here. So now no matter what, they still got chance to fall outside, right? So now even big, it is no use, right? Even big, it is no use, right? So you have to use some way to protect you, right? So now you can use right, use a pressed mattress. Place some soft mattress surrounding the frame of the trampoline. Press some soft mattress at here surrounding. Even if you fall, then you can fall under the mattress. All right. So if not, press some empty and use box. Alright, so empty unused box. I mean the unused box. Why? Because empty unused box, it is cheap. First of all, you put there when they fall on it. Alright, so now this one, both of this one is used to longer the impact time, right? To reduce the impulsive force. This one, you put some no use one, right? the box that no use at here, right? Especially here it is cement. Now this one is soft ground, it is okay. This one is glass, still okay, right? You don't need to do, right? You don't need to do it, will be okay. If you put this one at the cement, at the cement concrete way, then you have to put some soft thingy at here. Alright, now extra fitting, I put extra fitting here, extra fitting way, but I don't think so lah. Alright, where the knee protector, alright. I don't know what is that called. It should be called knee protector or what, knee or your arm protector, right? To prevent the injury of the children, right? So you can write this one, right? To ensure the safety, or you don't want, okay, you can wear helmet. You play trampoline, you wear helmet, alright. Alright, to prevent the injury of the children, right? Knee protector, helmet, or what other lah you think that is relevant. Okay, now that is all the answer. Now you see, now Arabic here, this one normal. Now if you don't answer this one well, alright, this one you answer okay. Alright, here, have a net surrounding the trampoline. Yes, I like this answer. I like this answer. Alright, net. You put a net there. Why? Alright. You put a net there. Prevent the user from falling to the floor. Yeah, okay. Logic. When logic, then yeah, okay. Now, any question that you want to ask me? Any question that you want to ask me from here? So if no, then you got any question, you can post into the group, or if not, then we are going to discuss this one. Alright, finish this one lah. Alang. Finish this one. Okay? Finish this one lah. This one. No need to save lah, this one. Okay, so we discuss this one, okay? If you got any other question that you want to ask me, then you can ask me. Or later, if we can finish earlier, we can do a bit of quiz for you, alright? Replay the quiz that previously that you had done. Okay. Set the hook law, okay? Now, 2020, set the hook law. Hook law is force applied onto the spring is directly proportional to the extension of the spring if the elastic limit is not exceeded. Right? Force applied to the spring is directly proportional to extension of the spring if the elastic limit is not exceeded. Okay. Calculate the spring constant of the M. Alright. The extension of spring is 4 cm. Extension is 4 cm. So now 1 kg hang on the M. Alright. Calculate the spring constant if 4 cm extension. So F is equal to Kx. F is Kx. F we are going to take 10. 1 times 10. 1 times 10. K don't know. Right? K don't know. Right? K don't know. Extension is 4 cm. But before I answered it, I takut whether they ask me energy or not. They don't ask, right? Do they ask me about energy? No, no energy, I use EM. Okay. If they got energy, then you use meter. Now you want to choose meter to use, okay or not? Can. Right? 4. This one is 4, I put it into cm. 10 divided by 4 is K is equal to 2.5 Newton per cm. If you use meter, it will be 250 Newton per meter. Will be okay. Both are okay. Right? Both are okay. Because they don't ask energy. Right? 2 mark here. Alright. Now, spring M breaks when it is hanged to the heavier load 3 kg mass. Suggest a modification can be made for the following aspect to able the spring to withstand the heavier load. You hang heavy, then it still can tahan one. Stiffness, alright? Right? Kekerasan spring, right? Stiffness, right? Higher stiffness. Higher stiffness of the spring, alright? So why? More energy can be stored. Right? Because the energy is half kx squared. Right? So your k high, energy also high. Thickness of the spring, thicker. Wire. Thicker wire. Why? Why you use thicker wire? So more stiffer. Type of the material. Alright. If you know, then we put steel. If you don't know, then you put stronger or harder. Right? Right? If you know, it is steel normally. Right? Steel. Why? Right? Not break easily. Or you can say stronger. Right? You see, you answer many times, then you know what will the answer give already. How to answer already. So the most important thing is how to answer. Right? How to answer. Okay. Alright. Identical spring N and N is hang together with M. Draw the arrangement of the spring so that it can hang heavier load without break the spring. Right? Here you got an M. You got an M. You got an M. And then identical N spring is hang together with the M. So how do you draw? So what you need to draw is you have to put them in parallel. Right? The spring, you put them in parallel. This is a spring M. This is a spring N. So you put them together. You hang something. So this one you label it, right? One of it is M. One of it is N. Then it will be okay already with just one mark. Okay. Alright. Diagram 5.1 shows a boy rocking elastic spring rocker. So diagram 5.2 shows the same boy with another spring rocker. Both are using the identical spring. One spring, two spring. Right? What is meant by elasticity? Elasticity is the ability of the spring to return back to its original shape and size after the force applied is removed. Yeah. Okay. This one, This one you're able to do it already. So if you've done it, you already done it, right? So the number of the string, compare. So 5.2. 5.2 more than 5.1. Right, 5.2 more than 5.1. Wait ah. This one I haven't set out. Give me one more, because I don't want to repeat one more time. Give me one. No. Yeah. Cannot, I don't want. 因为 from 4 和 from 4 Thursday on 4 and from 4 Monday one English version and Mandarin version, the file is different. So this one if I don't copy and paste mean later I have to do it one more time for you. You need to wait for a while lah. Okay. The compression of string. So 5.1 compress greater compression compared to 5.2, right? 5.1 the compression in diagram 5.1 more than 5.2, right? Compress more. Stiffness, all right? So stiffness of the string. So 5.2 is more than 5.1, right? Stiffness in diagram 5.2 more than 5.1, right? Diagram 5.2 more than 5.1. This one more stiff, harder to compress. This one less stiff because these two string together, right? Parallel. Relate the number of the string and the compression, right? The more the number of string, right? I put in this one connected in parallel, right? The more the lesser the compression of the spring. You can no need to put, because this is based on the diagram one, right? The more the number of the string, the less the compression will be okay. Because this one got diagram, right? But generally, when you write this one, you have to write parallel. You have to write parallel. Generally, without any picture, without any diagram, you cannot. The more the number cannot. Relate the stiffness and the compression. All right. The lesser the compression of the spring, the more the stiffness of the spring, right? If the more the compression, so the less stiff the string. You can compress mean it is not so stiff, 不会硬 not 不会很硬很软 okay. Now which spring rocker can support the children with greater mass? 5.2. Right? Now explain why, right? Because the spring are connected in parallel and it is more stiff, so it can store more energy. Diagram 5.2. Why? Because it is connected in parallel and it is more stiff, so it can store more energy, so it can support more children with greater weight. All right. Okay. We do number 8. number 8 with number 8 shows a trainee using a elastic pull sit up spring in her training, right? Pull here and then sit up, right? A spring is attached between the handle and the footrest of the spring sit up spring. So the force it is applied. Stretch and return to original position after the force is removed. The force applied can be determined by using the F is equal to X, where this one, right? Name the physical law. So name physical law. This is called Hooke's law. Hooke's law. Right, Hooke's law. The maximum force can be applied to the elastic sit-up spring. It is 450. What happened to the spring if the force is 500? What happened to the spring? You can tahan 450 only, but if you use 500, what happened? So now some of you will say break. Not necessary break. Not necessary. Alright. So it will not able to return back to its original shape and size. Right? So if you greater than this, you cannot able to turn back to original shape and size and shape. Too much. Why? Explain. Because. Right? Because what? Answer me. Because what? Because the force applied is exceeded the keyword. I just want keyword. Because the force applied is more than, yes, elastic limit of the spring. So 为什么? So they ask you why, alright? This one supposed to get 1 mark, right? Here, 1 mark, and then explain 1 more mark. That's why you got 2 mark here. Explain. Why cannot return? What will happen? So if you said break, okay, why? Then you answer too heavy, the force is too big. No mark. Yeah, I know logically it can be break. Yeah, it can be break, but not necessary. Okay. Suggest a modification to the spring so that it can withstand a bigger force, and give me the reason. Thickness of wire, right? Thicker, right? Why? Higher stiffness. Increase the stiffness, right? More stiff. Number of the string. This one not so good, but anyhow, here the string, number of string is 1, 2, 3. I mean, it should be in parallel. So they never say in parallel or series, but we understand it should be in parallel, right? So number of string, more number of spring, right? So more number of string, so higher stiffness, right? Same. Yeah, okay, same will be okay, right? Arrangement of the string, parallel, right? Why? Right? Increase the stiffness. Same. Higher stiffness, increase the stiffness, right? not more elasticity, more stiff, right? All same. Okay. Okay, last one. 5.1 shows a graph extension against the force of the graph for two springs J and K. J and K. Both have the same original length and made of the same kind of material. Now name the Hooke law. Force applied to the spring is directly proportional to the extension of the spring if the elastic limit is not exceeded. So Hooke law said that the force applied to the string is directly proportional to the extension of the string if the elastic limit is not exceeded. Compare the thickness of the string J and K. So they already said this same original length, same kind of the material. You see, this one is more stiff. Oh, sorry. Wait, I want to ask you, J or K is more stiff? Answer me. J or K is more stiff? Answer me. J or K is more stiff? What do you think? J or K? Chen Xi said J. How about others? Which one is more stiff? 比较硬 right? Some Shelly K, right? So now Hooke law said this is F, this is X, alright? See here? Okay, let's say this one I put it 5 Newton, 5 Newton, sorry, no, 5 cm, 5 cm, right? This one, let's say 2 Newton. This one, let's say 10 Newton. I need 2 Newton, then panjang extend 5 cm. This one, I need 10 to extend 5 cm. Oh, this one stiff. This one less stiff. Hooke law. But you see this one. You see this one. They purposely want to trap you. Right? Just now I almost kena also. Alright. You see this one. I need. I compare here. Read this one 10 Newton. You extend 2. This one 10 Newton. You extend 5. So this one is soft. 10 Newton. You go long 5. You extend 5 cm. This one 10 Newton. You extend 2 cm only. So hard to extend. J is stiffer. You need to see this one and this one. Y-axis and x-axis properly. Alright. Yeah, here wrong, it is okay. Right. Compare the thickness. Oh, should be J is thicker. Right. J is thicker than K. Calculate the spring constant K. K is 1 over gradient of the graph, right? 1 over gradient of the graph. 1 over gradient. So we find the gradient from here. Gradient of the graph is K. So it is 5. 5 divided by 10, right? 5 divided by 10 over 10, right? Which is 0.5 cm per Newton. Cm per Newton. Alright, this one is cm, cm per Newton, gradient of the graph. So 1 over gradient will be 1 over 0.5. So which is equals to 2 Newton per cm. Now I double check for a while whether they ask energy or not. You see, calculate the elastic potential energy. So I put this one in Newton per cm. I don't want, because later I takut I salah. Later then I substitute, you know. So this one got energy, so I won't put my answer as Newton per cm. I must put in Newton per meter. So this one is, I change it. This one is 5 cm, right? 5 cm is 5 over 0 0.05. 0 0.05 divided by 10. It is 0 0.005. 1 over 0.005. So this one is 1 over 0.005. You get 200. Okay? You get 200. So this one is Newton per meter. I will leave it into this way. Alright, you know why? Because they ask you about the energy. When you do, make sure you refer down. You check down there. What do they ask you? Right? Alright. Calculate the energy stored in the string when the extension of string is this 5. Right? So energy, elastic potential energy is, right? Elastic potential energy is half kx squared. Half kx squared. And elastic potential energy is half kx squared. It is equals to half. So hard for me to write half. Half kx squared. Energy is equals to half k. Just now we have calculated it is 200. X is 5 cm. 5 cm. So 5 over 100. Okay. Half kx squared. Alright. So what we have is 200 times 0.5 times 0.5 times 0.05 square. So I get 0.25 joule. I'll get 0.25 joule unit. Alright, that's the answer. 2 marks. Okay. Next one. Encik Rabi have a pack of sand with a mass 2 kg. He need 1.35 kg to build a replica with mixture of sand and cement. Right? You are asked to help Mr. Ravi to determine the length of the spring when it is suspended when a bucket of sand it is in, if the K spring is used. K spring is used. Right? So this one with sand. This one without sand, 6 cm. Original length 6 cm. With a pail lah, with a pail. Right? If you tambah the sand, then it will extend longer, right? Okay. Now, so from here, you are asked to help Mr. Lavi to determine the length of the string suspended when the spring K is used. Where is spring K? Spring K. Where is spring K? Spring K. Where is spring K? Spring K. What is the K? It is 200 Newton per meter. This one 200 Newton per meter Okay, now you are going to use F is equal to Kx, right? F F Ravi has a pack of sand with mass 2 kg. He need 1.35 kg of sand to build a replica with a mixture of sand and cement. Sand 2 kg. He need 1.35, either 2 or 1.35. He need 1.35 sand. He got a sand 2 kg, so he don't use all. I don't know why they want to put 2 kg here, right? I don't know why. So 1.35. 1.35 times 10 is equal to K 200. And then extension, I don't know. Right? 1.35 times 10, 13.5 divided by 200. 13.5 divided by 200. 0.0675 in meter. Because this one, 200 is in meter. So X gotta be 0.0675. X is 0.0675 meter, which is X is 0.0. I move 2 decimal, 6.75. 6.75 cm. Alright, this is your answer. You are asked to have. I am quite worried about this one, right? So what did they ask you? You are asked to determine the length of the string. Length of the string, so the length of the string is original length. It is 6. So length will be 6 plus 6.75. So answer is this 12.75 cm. Length of the string. If you fill with it, right? You fill with 1.35 kg. Now, I tell you, now sometimes you are not sure because this question they never said how much it is filled in, right? You fill in you said you need 1.35, right? So you fill in 1.35 or not, or you fill in 2 or not? You carry 2 kg for all of it, or you carry 1.35, we don't know. So you want to do one more, right? You put 2 kg here, you got 2 set of answer, it is okay one. In the exam, I tell you, if you are not sure which one, right? If you are not sure which one, so you can do both. You can do both. So I do both for you, right? Meaning that now, teacher, I am not sure they want 2 or what 1.35. I also not sure because the question telling me. So 2 times 10 is equal to 200 times x. So x is why 1.35 in kg? Force it is in Newton. mg. This one force mg. M times g. Force must be in Newton. Okay, either 2 kg or this one. So this one will be 0.1 meter. So this one 0.1 or 10 cm. Okay, so the length will be of the spring will be 10 plus 6. So answer is 16 cm. You can do both. All right. Is that okay for you? You can do both. I see whether this one got answer or not. But I think it is this one. I forgot the answer already. 921. 9. This one. Ayan. 9. Question number 5. Okay. Now. Okay. They use. You see the answer, huh? J is thicker. J is J elevator bar, right? 2 Newton per cm or 200 Newton per meter. Both are okay. 1 mark, 1 mark. Alright. So elastic potential energy, no matter what, you still need to change. Alright. So 6.62. Oh, they use G as 9.81. They use G as 9.81. Alright. So F is equal to Kx. F is Kx, huh? F is 13.5 times 9.81. Here, they use 13.5 times 9.81. 13.5 times 9.81. And 1.35, I'm sorry. F is equal to Kx. Mg is equal to Kx. M is 1.35 times 9.81. Right? K and then X. K is 200, I'm sorry. 200. And then X, I don't know. Right? We can find the X. X is 1.35 times 9.81. 1.35 times 9.8. 1.35 times 9.81 divided by 200. Divided by 200 equal 0.0662. 0.0662. So 0.0662, you move 2 decimal, 6.62 cm. 6.62 cm. Alright, they use 9.81. KSSM, you use 9.81. Because of, I told you, because of most of the time we want it to calculate easily, then we use 10. Right? Here, most of the time we want it to be easy, we use 10. But if they don't give, then you, no matter what, you still need to use 9.81. So I change this one. 9.81. So 9.81, this one is 662. 662. Okay, this one I cancel. Don't want this one, because if this one I still want to redo. Okay. Okay. Any question? Any question from here? Okay. So we continue the. I think last one. Second last or last? Second last. Okay. Let me finish this one. Diagram 8.1 shows one rod with a mass 1.5 kg is hanged at the end of the string. What is elasticity? Now this one I don't want to do already lah. So I do until like want to vomit already. Right? Don't want lah. Right? Ability of the spring to return. Or ability of the object to return back to its original shape or size after the force applied is removed. Okay. This one you go many times already. Based on 8.1. Calculate the elastic potential energy stored in the spring if the extension of the spring is 4 cm, right? 4 cm. So F is kx, right? Here, 8.1. Calculate the energy, elastic potential energy if the extension of the spring is 4 cm. So you got K, you got F. So energy, right? You got two ways to do it. I told you already. You got two ways. So I want to use the other formula. The other formula is energy stored in the spring is half Fx. So you no need to do 2 times, right? If you use kx squared here, half kx squared, you need to find the k, right? So here, because of I don't want to find one more time, so I use half Fx. Energy is equals to half F. Force applied is mg. M is 1.5. G is 10. 9.81. mg, and then x extension is 4. But I need to divide by 100. Why divide by 100? Because I want to change this one cm to meter, right? So half Fx. Okay, now half is 0.5 times 0.5 times 1.5 times 9.81 times 0.04. So what will I get? 0.2943. 2943. So answer is 0.2943. Unit joule. This one should be Sarawak one, right? Sarawak. 2021 Sarawak. We got 2021 Sarawak. Set what? Set 2. Set 2. Set 2, this one. Okay. Number 8, huh? 2943, huh? Right, 2943. Half Fx. Okay? Half Fx. 2943, yeah. Okay? Now, C. Diagram 8.2 shows a baby cradle that using spring P, right? Right? Spring P will be damaged is heavier, load is hang. Some modification need to be done to enable the support the heavier load, right? The baby getting fatter and fatter, right? So step a suitable modification, give some reason of the modification, right? So type of the material used for the spring, right? Type of the material. Steel, why? Harder or not stronger or not break easily. Okay. Thickness of spring, thicker. Spring wide, right? Stiffer. Arrangement of the spring, parallel, right? More stiff. Okay, so this is my answer. So we try to have a look at answer. Steel, right? Why? Right? If you don't want to write steel, like what I mentioned, you're not sure it is steel or not, you write strong material, it will be okay. So you write steel, you write strong. If here write strong, you don't write strong again lah. You write other. Okay. Now, hanya satu markah diberi if jawaban M1 and M2 adalah sama. Mean strong. Here you write strong Here or strong M1 M2 M1 strong M2 strong hanya satu markah. Meaning that if you cannot repeat the strong alright. Okay? You understand what do you want? Thick, why? Not break easily, high spring constant or what? Parallel, why? Force distribute to each spring is small. Right? They want this one. You see, they got no other answer. So my answer, I have to be just right. Force distribute to each spring is smaller. They want this. Right? More stiff, strong. Yeah, more stiff is correct. Not wrong. Okay. Next one. Let me finish this one. You got any question that if now you got any question, you can ask me into the group, right? You can ask me into the Telegram group. Post it into the Telegram group. Okay. Now, what is mean by elasticity? Can I skip this one? I don't want to answer already. It's so boring. Calculate the value of the spring constant for P, right? P, spring constant. So you find the gradient of the graph. F versus X. Okay, no problem. So 60 over 0.6. 0.6 is in meter. 60 is in Newton. So F is equals to Kx. F is 60. K don't know. X is 0.6. So K will be equal to 60 divided by 0.6 is 100 Newton per meter. Newton per meter. Okay, Newton per meter. Based on 6.1, 6.2, compare the thickness of the string. So this one, which one is thicker? This one, P or Q is thicker? P or Q is thicker? P or Q is thicker right now? What do you think? P or Q, it is thicker right now? What do you think? P or Q? Now it is P. Now, yes, now it is P. Yes, correct. This one it is P. Just now that one is Q. Good. Alright, very good. Right, thicker P. Right, no why. You don't need to answer why. Right, extension thickness. They ask you to compare. P thicker than Q. Then Y. Then Y then Q The answer wrong no, the answer, the question. I don't know. I should compare P thicker than Y or P thicker than Q. Whatever lah. Q lah. Normally it's Q lah, huh? This one I cancel. Sorry. This one should be Q. Extension of P and Q. Which one extend more? You can see P and Q. Q extend more. With the same lot Q extend 0.8. This one even you are more heavy, 60 Newton, but just extend 0.6. So extension of Q, extension of spring Q more than P. Spring constant from P and spring Q, right? Spring constant, you look at the gradient of the graph. Make sure F versus X, spring constant P is greater than Q, right? Spring constant P more than Q. Okay. Based on the answer 6B, state the relationship between the thickness of the string and the extension. The thicker the spring, the less extension, the less extension of the spring. When the spring is thicker wire, right? Thicker wire, so harder for it to extend, so less the extension. The spring constant, right? The thicker the spring, the more the spring constant, the greater the spring constant. The greater the spring constant. So what law related to this? Hooke law. Hooke law. Alright, last question. This one really last. Alright, finish this question. Diagram 11.A and B shows the same string suspended 1 and 3 Newton weight to study the elasticity of the string. Alright, 11.1, 11.1 B, A and B. 1 Newton, 3 Newton. Extend. Original length is here. This one extend a little bit already. This one extend a lot. Right? What is mean by elasticity? Skip. Don't know. Compare the spring constant. Right? Compare the spring constant. So now compare the spring constant. They are using the same string suspended with different weight. Right? Same string. So you compare the spring constant. Right? Spring constant will be same spring constant. Alright. Not enough space. Where should I write? I write it to here lah. Right. Same string constant in diagram 11.1A and 11.1B. Okay, next one. Compare the weight of the lot, right? Weight of the lot in diagram 11.1B more than 11.1A. B 3 Newton, A 1 Newton. So B is more than A. Okay. Next one. Compare the extension of string. Alright, compare the extension. This one extend more, this one extend less. Alright. Extension of string. Extension of the spring in diagram 11.1B more than 11.1A. Okay, so this one is 3 marks from here. Relate the weight of the lot and extension of the string, right? So relate the weight of the lot. The greater the weight of the lot, the greater extension of the string. Okay, and name the physical law. Physical law is Hooke law. Hooke law. Okay. Next one. Diagram 11.2 shows a graph of force against the extension of string for spring J. J. Right? F and X. See properly, F and X. Alright. Now, based on the graphs, right? Explain how the stiffness of the spring elastic potential energy stored in the spring can be determined. Right? This one we done it before. Right? So now first one you explain the stiffness is they ask you how the stiffness of the string can be determined. Right? Stiffness of the graph and stiffness of the spring. Spring is equal to gradient of the graph f x. Okay. No. Okay. Stiffness of the graph. Stiffness of the string is equal to gradient of the graph. Alright. So I better write the equation because I takut not enough mark. Right. F is equal to kx. Right. So stiffness of the string is equal to gradient of the graph. Right. I guess here I got the 2 mark. Right. Then the elastic potential energy, how to determine? So elastic potential energy is equal to area under the graph. Right. Area under the graph of F versus X. Where I takut where the X axis must be using the unit of meter. Alright, the X must be using the unit of meter, not in cm. Alright, so this is where I have 4 mark. 1, 2, 3, 4. But I guess paling banyak I get 2 mark only. This one and this one, the second and third, because I don't know what to write already. I don't know what to write. Kelantan 2022, last year. Not last year, this year. The 2022 is they prepare for their 2030 Kelantan. We open Kelantan. See the answer. Kelantan. Kelantan answer. Cross. And cross. I see question mark. 11. Question 11. Alright, this one don't want to see already. This one don't want to see. Alright, you see stiffness is measured from the spring constant. I don't have it. Spring constant is gradient of graph 1 mark. Spring constant F is equal to X. Okay, then you change. Energy is area under the graph. So I got the mark of here. Where is the mark? The mark that I get is now elastic potential energy is area under the graph 1 mark. Stiffness is 1 mark. Equation 1 mark. So now this one don't have mark. Where is I short of one thing, right? Energy stored in the spring is 1/2 1/2 kx squared. Energy stored in the spring is equals to 1/2 kx squared. This one will give you 1 more mark. So 1, 2, 3, 4. This one no mark. This one no mark. Okay, you can see from here. Now stiffness is measured from the spring constant. Right, where spring constant is gradient of the graph. Okay, I need to add in one more. Right, stiffness is equals to the gradient of graph. Okay, now stiffness is measured from spring constant. Okay, F is equal to X, where uh, stiffness is measured from the spring constant, where stiffness of the spring is equal to the gradient of the graph. Alright, this one 1, 2, 3, and then 4. Okay. Alright. Okay, last one. You are asked to create a swing that can be used by adult or larger mass. Right? Heavier one. Right? Give me your suggestion. Right? Give me your suggestion. So diagram 11.3 shows the swing is sitting by a children. The spring of the swing was extended when the children is seated. Alright, so this spring longer. Okay, now they don't give you any idea. They give you set and explain your suggestion based on the characteristic of the cattle and the spring. So I give you 5 minutes to try to do this. You can send it to me. You can send it into the Telegram group. I can mark for you. I can mark for you. You can mark on your own. See how to do it. You mean I read one more time? Diagram 11.3 shows the string is sitting by the children, right? So the spring of the string, it is extend, right? Go longer, right? When he sit. Then now your friend got a fatter friend come to your house, or you and your friend want to sit together. Then it takut cannot tahan. So how to make it more larger mass, right? To sit on it also can tahan one, right? Listen. 5 minutes. Now it is 3:04. I go toilet for a while, rest for a while. Then we continue after 5 more minutes. Alright. You take a rest. You do it. Take a rest and do it. Alright, I go toilet for a while. You can do it. Already? You can send it to me. You can send it to me. Yeah, before you forgot, I do a bit promotion. You are interested to my tuition? My tuition fee will be 65 ringgit per month. Online tuition, online only. So you can click this link to register if you want. All right, already 5 minutes. How is it? I also do it. I'm not sure whether I can get correct or not. Hmm. Shorter spring. Stiffer. Yeah, Chen Xi sent already. Good. Right. Letter Ahmad, I do it also. Thicker wire, larger spring constant, alloy spring. Alloy spring. Steel will be better. Wait. For me lah, steel will be better. Shorter spring, size of the best wider, bigger size of the nest, alloy or steel pour. Okay, good. Why? This one normally you will not put outside. Non-rusting, not so good. Alright, you can choose longer, last longer will be better. So you put 2 will be okay. Right? Normally, this one it is put into the house, right? Normally it will not kena water. Larger spring constant. Okay. How about others? Shorter spring. Shorter spring, large, bigger diameter. So why? Can I don't want to write the same one. Can withstand more force, right? More weight. Higher spring constant. Or I can write the higher spring constant also. So steel spring. Hey, this spring I write wrong. Material using steel. Okay, Charlotte sent already. Wait, I see your answer. Use thicker spring, use more number of spring. More number of spring 不好。对了 more number of spring 不好，为什么？因为你要讲 parallel 比较好。More number of spring connected in parallel 这个就 OK. These two combined together. Okay. Greater area of best. Use a seal pore. Okay. Okay. Wait. Shorter spring, stiffer, smaller diameter. Smaller diameter. Okay. Smaller diameter. Okay. Can store more energy. Soft spring. Soft spring. Soft spring is not correct. Stronger material for cattle. Okay, this one okay. Right. If you're not sure which material, you can say stronger material. Thicker spring, yes, more stiff. Okay. Yeah, okay. Bigger diameter of the wire. I write wrong. Bigger diameter of wire. Yeah, you see? Of the wire. Right. Material is steel. Okay, why? Higher spring constant. Smaller diameter of the coil or the spring, right? Stiffer. Okay. 1, 2, 3, 4 already. Higher spring constant. Right. Stiffer, right? I don't know what to write already, right? Increase the stiffness of the spring. Okay, so the more that you write, it is better. All right, so now 1, 2, 3, 4, 5. I got 5 already. So this one enough already. So I want to write more others on this one. Right, state and explain your best on the characteristic of the cutter and the spring. All right, cut spring already. So the best area, bigger best area. So more stable. Right, bigger best area, increase the stability. I see more here. The nest, best area of the nest bigger, right? So it is more stable also. More stable. The paw. All right, now the paw. All right, the paw. Use a stronger material. Right. Okay, so I think that's good enough already. Alright, I think this one is good enough already. So we try to have a look on the answer. Answer Kelantan. Okay, now the answer is bigger size of the nest. Alright, bigger size. So they want bigger size. Bigger size I don't have. Alright, bigger nest best area. Okay, so not same. So I won't have the mark. Right, now the material of the paw, it is strong or steel. Right, strong or steel. Yes, strong or steel. Here I got 1 mark. Stronger material, right? Not break easily. Right, 1 mark. Okay, the size wider, bigger. All right, not more stable. Okay, the best area, bigger best area, increase the stability. Okay, 1 mark. Next, steel spring, not rust easily. Steel spring, okay. Steel material of the spring, steel, okay. Higher spring constant, not rust easily, okay. Boleh lah. Right, this one same one. Right, they use not strong or not rust easily. Short, diameter smaller. Diameter of the spring it is bigger, so all of these are spring is more stiff, right? Extend lesser, right? Or larger spring constant, so all of these are the same, right? So this one will give you the mark, right? Shorter spring, stiffer. Smaller diameter here. Higher spring constant, no mark here. Bigger diameter of the wire, right? Or thicker wire. If you don't want to make them confused, thicker wire will be okay. So can withstand more weight. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. But more than the mark that they give already. You see, this one is 2, 4, 6, 8, 10, right? 10 mark, 12, and 14. Maximum you get 10 marks only. So they will give you extra one. You don't need to worry, right? You don't need to worry. Is that okay for you, right? So now I mark for you. You see, your answer. Wait, okay, I mark for you right now. Shorter spring, stiffer, okay. Smaller diameter of the spring. Yes, sandstorm or energy, okay. Soft, this one cannot. Right? Should be hard, And then stronger material for the harder. Not break easily. This is not under the answer. Thicker spring wire. Yeah. Okay. So this one will 2, 4, 6. This one not under the answer. Alright, not under the answer, so I cannot give you the mark. 6/10. Alright. 6/10. So I mark for you this one. Now, the more that you write, it is better. Okay. Thicker spring, yes, stiffer. Larger spring constant, this one not under the answer. Alloy spring, don't have it. They want steel. So you see, the one that I want to show you is, now you see this one, the answer is material of the pole, right? Sorry, material of the string is steel only. So if you are not, you don't use this one, then they will not give you the mark. So you need to be very, very careful. So this one you won't get the mark, alloy. So won't get the mark. So shorter spring, yes. Right, size of the string, best, bigger, okay. Right, bigger size of the nest. Yeah, this one is under the answer. Can put more lot size. Right, steel paw, okay. This one okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you got an extra one, no mark one, it is okay. Right? So this is full mark. Right? This one is full mark. One more. I mark one more for you, which is shadowed. Okay. So you don't just write 5. You write 5 only. You see, that's the problem. You see, use the thick wire. Okay, not break easily. More number of string. This is not under the answer. Right? No, 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 no. Right? Greater area of the best. Okay. More stable. Okay. Use a steel pole. Okay. Okay. So you write 1, 2, 3, 4, 5. 你写准准给他哈。你有一个两个错后面都没有分了。So you have to write extra one. They got extra give you. You understand what am I saying here? This how to score it. Right, so this one is 你看很可惜你拿6分而已。Is that okay? Do you get what I mean here? Do you get what I mean here? This one is the skema pemarkahan, right? This one is a schema pemarkahan. Yes, write more. 好，比如这几个你要写下去。 你要写下去，不是这几个，你那个 increase the spring constant 的话，你要写完下去，你能写的你就写下去，好，就算错他没有扣你分的，你不用怕的啊。If wrong, they will not minus your mark. You say you don't purposely write like bigger best no bigger diameter of the spring like what I do lah just now lah, okay. You see if I wrote this just now I write wrong bigger diameter of the spring this one is wrong so this one no mark this one no mark this one even correct then they will not give you the mark. So how much should I get? 1 2 3 4 5 6 7 8 9 10. I still get mark 10 mark. Even one I write wrong but I still get full mark. Do you understand? Write the extra one 写错不要紧的。 Okay, any question? Any question? Any question here? Any question here? So next week we are going to go for the new chapter already. Alright, chapter 2, pressure. Alright. If no question, then I am going to stop here. Thank you for your attention. I will send you this one letter. I'll send you this one letter, Right? Because I need to copy and paste. Alright. Okay. See you. See you. Alright, see you. See you on the next lesson. Bye bye. Bye bye. Bye bye. Bye bye.